All right, welcome everybody, fifth graders, coding and game design kids. This is awesome. I have a very special treat for you today. I have an amazing story to share with you about quantum supremacy. How many of you, by show of hands, know what quantum supremacy is? Probably one, maybe nobody, because guess what? Your teacher had no idea it was until this person I'm about to introduced me to it, and then a series of events happened that are pretty amazing. And you guys are going to get to hear about all of those events. So I would like to introduce to you a former Monroe alumni. Alumni means somebody that's already graduated and now is coming back. Okay, he's a sixth grader. And he's coming back to share something amazing with you. Last year, because he told me he wanted to be a teacher or a professor someday, he got to present a lesson last year to the fifth graders, like during math, a whole fifth grade lesson. So I dubbed him Professor Herrera. Okay, because he said he wanted to teach college someday, because his last name is Herrera. So with no further ado, a big round of applause for Professor Herrera.
All right. So what?
Let's go.
What is quantum supremacy? First, I would like to just explain how a normal computer works. A normal computer works on the operations called bits. Bits are ones and zeros. These ones and zeros then get manipulated by logic gates, and then you can make programs such as games like Minecraft, productive software like Google Docs, and then supercomputer software such as weather forecasting. So what is quantum computing? Quantum computers operate on a very different principles. They use qubits, which instead of using ones and zeros, they use a probability of 1 and 0. So what that means is that you can get all your calculations done probably the first try. And then there's this other property called entanglement, which means you can put a qubit and another qubit any distance apart, like it could be millions of light years, which is like the speed of light for a year, and they are still connected. And then there's the fact that quantum computers literally have to be cooled to like 12 microkelvin. Or also colder than interstellar space, or also another example would be negative 460 degrees below zero. And then there's this little funny slide we made. Alright, continue. What is quantum supremacy? Quantum supremacy is when you have a quantum computer that can run a task much faster than the biggest supercomputer on Earth. Would you like your Big Mac in 200 seconds or 10,000 years? And then we're gonna play a video.
Can you make it big and full screen? Do you know how to do it? Oh, can you pause it? I just gotta turn the sound. Nope, gotta go back one. Sorry, it's okay. Okay, wait, make it big. I forgot to turn the sound. Can somebody grab the lights? So what Julian was trying to explain.
The tantalizing promise of quantum computers is that they can do certain tasks exponentially faster than classical machines. And the quantum supremacy experiment is proof that this is indeed the case.
The word quantum computer is a little bit misleading because it sounds like a computer. And when people think of computer, they think of a phone or a laptop. The truth is, the phone and the laptop and even a very powerful supercomputer all operate according to the same fundamental rules. And a quantum computer is fundamentally different.
Can you pause
Classical bit.
Okay, so look at that. The computer you just saw is totally different. That's what a quantum computer is, that picture you just saw. And this guy right there, just take a look at him quick. I know we paused him in a weird way. Check out his shirt. It's gonna matter later. Play it.
Stores information as a 0 or 1, and a quantum bit can be both a 0 and 1 at the same time. If you have 2 quantum bits, then there are 4 possible states that you can put in superposition. With 3 qubits, it's 8, 4 qubits, it's 16, it grows exponentially.
The nice thing about quantum supremacy is that it is a very well-defined engineering milestone.
In a nutshell, what we're trying to do is we're trying to show that experimental quantum computers can surpass the best supercomputers in the world.
To actually demonstrate quantum supremacy, we have these 3 steps. First, pick a circuit. Second, run it on the quantum computer. Third, simulate what the quantum computer is doing on a classical computer. We gradually increase the complexity of that circuit. And at some point, it becomes completely impossible for the classical computer to keep up. Then we say we've achieved quantum supremacy.
We started building together the quantum chips to do this experiment. And then the evolution of the devices was more and more qubits and more complexity. It's very much an iterative process.
A lot of the work that we put in was not just these chips, but is also the infrastructure that you need to drive those chips.
So what they're building now is what a quantum computer looks like. It certainly doesn't look like this.
All of this stuff is needed, and it all has
They're
to be
inventing
developed.
something brand new that nobody's ever done. And that's to keep it cold.
When the experiment started, we were getting data from the experimentalists. We saw initially a beautiful straight line corresponding to our predictions.
Then, right before we hit supremacy, they dropped much faster and it fell below the threshold where it needed to be.
And there's nothing we can do because we don't know how to analyze past that. So everyone's like, oh, we're screwed because it's getting really, really bad at large number of qubits.
It's like, well, maybe there's some really complex interaction between all the qubits.
It turned out that the reason was rather benign. We calibrated it a little bit better and this problem disappeared.
So there wasn't like a, oh, we did it. I think we crossed it, and then it wasn't clear that we crossed it, so we crossed it a little bit further.
It took me like a day to realize, like, hold on, this is actually experimental data. It's kind of amazing to see, how well the theory works.
The processor that achieved quantum supremacy is called the Sycamore processor.
And it's parallel
Sycamore processor.
2 to the 53 states, which is 10 million billion. And thus that enormous amount of parallel processing is what gives it the power.
When we run small chunks of the computation, it's the largest supercomputer in the world. Our estimate is that it will take thousands of years to complete.
Look at
the
3
full
minutes.
computation.
Their Sycamore chip can beat a
Technologies
supercomputer. It would take it
it
10,000 years to do the same thing.
Started with a satellite orbiting Earth, and it was not doing much. It was just beeping.
The big technical achievement of quantum supremacy was really
That's their team.
dependent on all this young talent who's kind of taken this and gotten it to work at a very technologically capable level.
We have reached a new computational capability. There are certain computations, the only place in the world where you can compute those things is here in our data center at Google Santa Barbara.
For the first time, we're showing that we can solve a problem that is just infeasible to do on the biggest computers ever made by civilization.
And what's exciting is now we're ready to turn this over to the world and say, let's figure out what we can do with this.
Eric, there's Eric.
The thing that excites me most is building a useful quantum computer. When we can give a researcher a tool that is unlike any other and say, great, figure out something cool to do with it. Mankind is pretty good at that.
Okay, pause it. Pause it. Can you get back to the slides? You know how to get back to slides? I think you push escape. You go over to the, yep, you're awesome. Okay, go to the next slide. Okay, so Julian, can you hand it over to me for a sec?
Yeah.
Okay, so here's the story. Julian, okay, is a 6th grader, right? And I still work with him. I go to his house once a week, and we like work on different stuff. And when I went to his house, this is like about a month and a half ago, he said to me, he goes, "Oh, Mr. Manderfeld, Google accomplished quantum supremacy." And I went, "What? I don't know what that means," right? So Julian taught me what quantum supremacy is. And it's basically their new quantum supercomputer, or their quantum computer, I'm sorry, which they're just inventing, can beat a supercomputer, right? It was faster. That's why Julian did, would you rather like a Big Mac in 2.5 minutes or 10,000 years? Well, 2.5 minutes, right?
It's actually 3.5 minutes.
Or 3.5 minutes, it's okay. So we were very close, right? So when the whole thing went, after he told me this and he showed me this article from Nature magazine about quantum computers, and he taught me the stuff that I never knew, I said to him, after all that, I go, "That's cool, Julian." I go, "But guess what? you know there was that guy in the video that had that shirt, Sycamore shirt? I go, wouldn't you be the coolest middle schooler in the world if you could get a Sycamore t-shirt? And then Julian understands I was kind of joking, because Julian's like, yeah, that would be super cool, but I don't think any other middle schooler in the world wants a Sycamore t-shirt, because would they even know what it means? No. Because remember, Sycamore is the name of the chip that's inside of their quantum computer, so it's basically the name of their quantum computer, and it's the name of their team at Google, right? So I said to Julian, I go, Julian, you know what we should do? We should email the guy in that video, right? Why not? Because we saw his name. And we should ask him for a t-shirt. So I wrote him this email. I said, my name is Nathan Manderfeld, and I'm a 5th grade teacher at Monroe Elementary in Palm Desert, California. One of my students, Julian Herrera, is very interested in your work on quantum supremacy. This past week, he brought a Nature article from October 2019, was very excited to tell me about Google's process with quantum computing. I have to admit, this was over my head, means I didn't understand any of this, until he taught me. He explained to me about qubits and quantum supremacy. He showed me a video on YouTube, and I thought that was amazing. So this is what I asked this guy. Okay, he's a professor at Santa Barbara and on the Google quantum supremacy. I say, first, I wanted to share with you that students as young as 12 years old, meaning Julian, are very interested in your research. Second, it would be amazing if somehow Julian could get a Sycamore t-shirt like the one you were wearing in the video. I know it is a big ask, but there can't be too many teenagers running around with Sycamore quantum computing t-shirts on, right? So I asked him for it. And then I said, your Nature article is very inspiring too, and I quoted their article. Just like you guys quote, remember how Miss Lindsay? I quoted the article because it sounds really good, because it basically says that they're one algorithm away from making an amazing scientific breakthrough. And I said, well, guess what? Maybe somebody like Julian, 12-year-old, or you guys coding and game design kids will someday make that breakthrough. That will change the world, right? So we send this email off, and Julian was amazing because guess how long it took him? He's very good with computers. Guess how long it took him to find this guy's email? Like a minute. Just went on the computer, boom, boom, boom. Remember?
Yeah.
Yeah? He gets me his email. We send the email, right? So at that point, I'm like, that was pretty fun. That's pretty cool. But I didn't know if anything else would happen, right? So I wait. All of a sudden that night, my Gmail goes ding, and I check. Go to the next slide. And I get this email, okay? Thanks for the kind email. I will see what I can do. These t-shirts might have run out because they were only for the team at Google. They didn't make these t-shirts and sell them. You can't go buy them in the store. They're just for the people at Google that made this this quantum computer. He said, but I always can send you another design, John. Okay, that's the guy in the video, right? So the professor actually emailed us back, so I was excited. I was like, oh, that's cool. And I was going to tell Julian about it, and then Julian, come back up.
All right.
Then about 15 minutes later, I got another email from Eric Lucero, who is the head of the Google team, quantum computing team, right? And he said, you know what, I think it's amazing. I'm sorry we don't have any more t-shirts, but what did he say? I'm going to
make you some more.
He said, as long as Mr. Herrera, Professor Herrera, gets to present, he goes, I'm going to make brand new t-shirts just for your 5th graders, and I'm going to send them to you. And guess what? They sent them. So, Julian, unveil.
Alrighty. It's t-shirt time.
Okay, so bring it over so they can see the camera.
It's t-shirt time, children.
So Google took its money and cared enough about education to not only get Julian and I, Julian high five, Sycamore t-shirts. They got enough t-shirts for kids that actually care about computing and supercomputing like you to get you t-shirts, Sycamore t-shirts, and on the back, look at Google Quantum Team.
Google.
So what do we think about that? Awesome. You want to say anything else?
Yeah. You all get a t-shirt.
Woo!
And you get